You ever get the feeling that there's some kind of secret code running the world? Well, there is, and it's called a function. By the end of this, you're going to see how this one simple idea from math is the engine behind everything from your weather app to your Netflix account. So let's dive in. I mean, how does your phone know it's going to rain tomorrow? Or how does your favorite streaming service figure out your bill so perfectly every single month? It feels like magic, right? But nope, it's actually just math. And it all boils down to just one single, powerful idea. A simple rule that connects what you put in to what you get out with perfect predictability. And today, we're going to master it. All right, so let's just forget all the complicated formulas for a second and start with something we all get, a vending machine. Turns out this is honestly the perfect way to understand what a function is all about. So what even is a function? Here's the deal. It's a special rule where every input gives you exactly one output. Think about that vending machine. You press button A3, that's your input. You get a bag of chips, that's your output. Every single time you press A3, you get chips. You never ever press A3 and get both chips and a soda. Nope. One input, one predictable output. That's it. That's the core idea. Let's make this crystal clear. What if we have a rule that matches a student to their age? Is that a function? Yes, for sure, because every student has exactly one age. But what about a rule matching a student to their favorite colors? Now, if Alex loves both blue and red, that rule is not a function. Why? Because that single input, Alex, is giving you two different outputs, and that breaks our exactly one rule. Okay, so we've got the main idea down. Now we've got to learn to speak the language. See, mathematicians have this special shorthand for functions called function notation. It might look a little funky at first, I get it, but trust me, it's incredibly powerful. This is what you'll see. F of x equals y. Let's break that down real quick. The f is just the name of our function, kind of like a name for a recipe. The x inside the parentheses, that's our input. It's what we're putting into our rule. And the y on the other side, that's the output, what we get after the rule does its magic. And here it is, the number one mistake people make. So listen up. When you see f of x, you read it out loud as f of x. It does not mean f times x. A much better way to think about it is like you're asking a question. Hey, function f, what do you do with my input x? Let's actually see this thing in action. Here's a classic, the function for converting Celsius to Fahrenheit. So what if we want to find f of 100? That's just a fancy way of asking, what's 100 degrees Celsius in Fahrenheit? Well, we just pop 100 in for C, run the numbers, and boom. Our output is 212. See how that worked? Input 100, output 212. Perfect. Okay, this is where it gets really, really useful. Let's use this idea on a real-world problem, like figuring out how much a car ride costs, and you'll see how we can use these things to work forwards and backwards. So here's the deal. An Uber ride has a flat fee of $3, plus it's $1.50 for every mile. Pretty simple. So how much is a 5-mile trip going to cost you? Our input here is the distance, 5 miles. What's the output going to be? $10.50. And how'd we get that? Easy. It's the $3 fee plus those 5 miles at $1.50 each. That's a function doing its job. The distance was our input and the total cost was our output. But wait, what if we flip this on its head? This time, you look at your receipt and you already know the output. The ride cost you exactly $18. So the question is, what was the input? How many miles did you actually travel? That was a 10-mile trip. See what we did there? Instead of just plugging a number in, this time we were solving the function. We took our rule, the $3 fee plus $1.50 times the miles, set it equal to 18, and we worked our way backward to find the input. It just shows you how flexible these things are. So we've seen functions as rules and equations, but what about when you see them as a picture? A graph? Well, it turns out there's this brilliantly simple visual trick to spot a function in seconds. So you're looking at a chart with all these squiggly lines on it. Is there some way to tell just by looking which ones are functions and which ones aren't? Absolutely. And it's all thanks to something called the vertical line test. Okay, the rule is so simple. If you can draw a single vertical line, just a line straight up and down, that touches the graph in more than one spot, it is not a function. And why does that work? Well, a vertical line represents just one input.
If it hits the graph twice, that means one input is giving you two different outputs, and that breaks our vending machine rule.
Just take a look. The U-shaped parabola on the left, it passes with flying colors. No matter where you draw a vertical line, you're only going to hit that graph one time. So it's a function. But now look at the circle on the right. Whoops, you can easily draw a vertical line that hits it twice. One input, two outputs. It fails the test. Definitely not a function.
All right, so we've defined what a function is, we know how to speak the language, and we've even got a cool visual test for it. But here's the real takeaway. Now that you know what to look for, you're going to start seeing functions everywhere.
I mean, seriously, think about it. Your phone bill is just a function of your data usage. The calories your fitness tracker says you burned, that's a function of how far you ran. Your streaming subscription price, your delivery costs for online shopping, your follower growth, even your score in a video game, they're all functions. It's like the hidden operating system of our world.
So I'll leave you with a little challenge. Now that you know the secret rule, one input, exactly one output, what's another hidden function that you use every single day? Trust me, once you start looking for them, you won't be able to stop seeing them.